Hi guys, today we are going to discuss about the second lesson of physical science, which is chemical reactions, as well as we can say it as in this lesson we are going to discuss about how to balance a chemical equation, and we are going to solve different problems which are based on mass, volume and number of molecules, etc. So this session is also useful for the Andhra Pradesh as well as Telangana boards. So let's start the session. So first of all, we will discuss about, as we have discussed, we will discuss about the worksheet. So this is the worksheet, you can see it. There are some questions are there. We are going to discuss each and every question which is given here, and I'll put some questions where you can able to answer yourself. So first of all, you can see it. The first question is define limiting reagent. So what is called as a limiting reagent? So first of all, let me tell you, limiting reagent is, okay, let us take a chemical equation. C plus O2 gives rise to CO2. Okay. Now you know the atomic mass of carbon, which is 12, and oxygen, this is 2 times of 16, which is equals to, this is 12 plus 2 times of 16. So now we are going to calculate it. 12 plus 32 gives rise to 12 plus 32. So this is 12 plus 32 gives rise to 44. Now try to understand this equation. So 12 grams of carbon react with 32 grams of oxygen to produce 44 grams of carbon dioxide. Try to understand what I am saying. 12 grams of carbon reacts with 32 grams of oxygen to produce 44 grams of carbon dioxide. Now if I ask you, if 6 grams of carbon is going to participate in the reaction, then obviously it requires 16 grams of oxygen. So 12 grams of carbon requires 32 grams of oxygen, then half of 12, which is 6, then obviously half of 32, that should be 16. What happens if 16 grams of oxygen is not there and we have only 10 grams of oxygen? Now I am not going to say that the reaction won't happen, the reaction will happen. But you have to understand here, the oxygen is the reactant which is available in the less quantity than required. Actually we require 16 grams for this 6, but here it is 10 grams. So are you understanding what I am saying? That means if the reactant is available in the less quantity than required, then that reagent is what we called as limiting reagent. So what is called as limiting reagent? So now hope you can understand what is limiting reagent. The reagent or the reactant which is available in the less quantity than required, then that reagent is called as limiting reagent. So this is our first question answer. So what is limiting reagent? So our answer is, if the reactant is available in the less quantity than required, then that reagent is called as limiting reagent. Okay. Now we'll go to the second question. So the second question is, give an example of exothermic reaction which occurred naturally. So let me tell you what is an exothermic reaction first. What is an exothermic reaction? So an exothermic reaction is a type of chemical reaction in which heat is released or heat is liberated. In which chemical reaction the heat is released, that reaction is called as exothermic reaction. So what is exothermic reaction? The exothermic reaction is a type of chemical reaction in which heat is released. So whenever heat is released in a chemical reaction, then that reaction is called as exothermic reaction. For example, you take zinc granules and make them react with dilute hydrochloric acid, then you are going to have zinc chloride and hydrogen gas is going to be released. This reaction is going to be happen in a conical flask. If you touch the walls of the conical flask, you are going to find it was hot. then obviously in this reaction heat is going to be released, that is plus Q. Q means heat, quantity of heat. So now what is an exothermic reaction? The chemical reaction in which heat is released is called as an exothermic reaction, but he has asked a chemical reaction which occurs naturally. What is the best example of exothermic reaction which occurs naturally? Our answer is respiration. You all know in respiration heat is released. That's why respiration is the best example of an exothermic reaction which occurs naturally. Now look at the next question. Give an example of endothermic reaction which occurs naturally. So we have to give an example of endothermic reaction which occurs naturally. So what is an endothermic reaction? An endothermic reaction is a chemical reaction in which heat is involved. Okay, the chemical reaction in which heat is involved is called as endothermic reaction, and you all know the best example of endothermic reaction is photosynthesis. So photosynthesis is a chemical reaction which is occurred in the plants only in the presence of sunlight. Sunlight is a form of heat energy and it is going to involve in this energy in this reaction. That's why we can say photosynthesis is the best example of endothermic reaction, whereas respiration is the best example of exothermic reaction. These two reactions are naturally occurred endothermic and exothermic reaction. So now tell me, what is the best example of natural reaction of endothermic? Answer is photosynthesis. Best example of naturally occurred reaction which is an example of exothermic, that is respiration. So hope you understand these two questions. Naturally occurred endothermic, respiration, photosynthesis. Naturally occurred exothermic is respiration. Now we'll go to the next question. So what is the next question? What type of reactions we observe when quicklime is added to water? So tell me, what is the chemical formula of quicklime? Quicklime is CaO is called as quicklime. When it is added to water, then what is going to form? We are going to find lime water, that is CaOH taken twice. And remember, while you are going to touch the walls of the beaker, you are going to find heat. That's why it is an example of exothermic reaction. It is a exothermic reaction. So now tell me, what happens when quicklime is added to water? It will produce lime water or calcium hydroxide, and this is an example of exothermic reaction. Now we will skip to the next question. So our next question is which gas is released when zinc is added to HCl? How do you test the gas? Which gas is released when zinc is added to HCl? Okay, we have already discussed. When zinc granules are added to dilute hydrochloric acid, then it will produce zinc chloride and a gas named hydrogen gas. And how do you test the hydrogen gas? If we introduce a burning splinter, it will produce pop sound. So pop sound is the best test for the hydrogen gas. Whenever we introduce a burning splinter, it will produce pop sound. That's why, what is the test for the hydrogen gas? If we introduce a burning splinter, it will produce a pop sound. What is the test for the oxygen gas? It will burn the splinter brightly, vigorously. And what is the test for carbon dioxide? It will put off the fire. Carbon dioxide can put off the fire. That's why it is also called as fire extinguisher. Carbon dioxide is called as fire extinguisher. And it can turn lime water to milky white. It can turn lime water to milky white. Okay, these two you remember. Okay, hydrogen gas, pop sound. Oxygen burns brightly, vigorously, and carbon dioxide, it can turn lime water to milky white, or it can put off the fire. That's why it is called as a fire extinguisher. So which gas is called as fire extinguisher? Our answer is carbon dioxide. So here, whenever zinc granules are going to react with hydrochloric acid, it will produce a gas named hydrogen. If we want to test hydrogen gas, we have to introduce a burning splinter to it. It will produce a pop sound. Now, which gas is lightest of all the gases? Which gas is lightest of all the gases is the question. What is our answer? Which gas is called as lightest of all the gases? You may be thinking of helium because it is going to fill in the balloons. Our answer is hydrogen gas is called as lightest of all the gases. After hydrogen, it is helium. That means in the options, if hydrogen and helium both has been given, you have to write hydrogen as the answer. If hydrogen is not there and helium is there among other options, then you can go for helium. Okay, so which gas is called as lightest of all the gases? Our answer is hydrogen. Okay, we'll go to the next question. Balance N2 plus O2 gives rise to NO, and what information you can get from the reaction? We have to balance it first. We have to balance N2 plus O2 gives rise to NO. N2 plus O2 gives rise to NO, and here it was given as minus Q. Okay, N2 means nitrogen gas. Now you can see here how many nitrogen atoms are there? 2. Oxygen, how many oxygen atoms are there? 2. This is a reactants. And look at the product side. Here how many nitrogens are there? 1. How many oxygens are there? 1. Can we write 2 and 2 here and here? No, we can't write like that. We can't change the subscript. Now, if I am going to write 2 here, then what is going to happen? It will become 2 nitrogens and 2 oxygens. And now it was balanced because before the reaction, the reactant atoms are 2 and 2 here. After the reaction, here we are going to find 2 atoms and 2 atoms. That's why it is a balanced chemical equation. So what happens if an equation is not balanced? It will violate law of conservation of mass. So what is the meaning of minus Q here? The minus Q indicates it is an endothermic reaction. So whenever plus Q is there, we can say that is an exothermic reaction. Minus Q means it is an endothermic reaction. That means it is involved in the chemical reaction. So this reaction N2 plus O2 gives rise to NO is an unbalanced chemical equation. And now we balanced it. Now we are going for the next question. What is that? C3H8 plus O2 gives rise to CO2 plus H2O. And verify law of conservation of mass. Okay. C3H8 plus O2 gives rise to CO2 plus H2O. So first of all, we will write the equation. So the equation is C3H8 plus O2 gives rise to CO2 plus H2O. So I'll tell you one thing. Here, what are the end products? CO2 and H2O. So whenever CO2 and H2O are the end products, then obviously this reaction is a combustion reaction. So now I will tell you a small technique. So whenever you are going to see a combustion reaction, easily you are going to balance it. Okay. First we will check whether it is a balanced or not. How many carbons are here? 3. How many carbons are here? 1. Then obviously it is a unbalanced chemical equation. Now we are going to balance it. So I'll tell you the technique. Whenever you are going to see a combustion reaction, you please apply this technique. It is the easiest way to balance a combustion reaction. Now, step number 1 is balance carbons. Always balance carbons on both sides. So first step is balance carbons. So how many carbons are here? 3. So here you write 3. Carbon is balanced. Now the second step is balance hydrogens. Okay, second step we are going to balance the hydrogens. So how many hydrogens are here? 8. How many are here? 2. That's why I can write 4 here. Now see, 4 2s are 8. Now look at the third step. A little complicated but easy if you are going to understand. Count the number of oxygens on the products. So total how many oxygens are here on the product side? Now this is 6 plus these are 4, then total 10 oxygen atoms are there. So what is the number here? You write by 2 here. So 10 by 2. What is 10 by 2? 5. So balance it now. Write down C3H8 plus 5O2 gives rise to 3CO2 plus 4H2O. Now look at how many carbons are here? 3. How many carbons are here? 3. How many hydrogens are here? 8. How many hydrogens are here? 8. How many oxygens are here? 10. How many oxygens are here? 3 2s are 6 plus 4 is equal to 10. Isn't it a balanced chemical equation? Easy? It is the best way to balance any combustion reaction. Shall we go for another example? Okay, I'll give you another example. We will solve that also. So whenever you are going to see a combustion reaction, you please solve by this method. It is the easiest way of solving it. See, I'll give you an example. C4H10 plus O2 gives rise to CO2 plus H2O. Okay, you are seeing CO2 plus H2O here. Then obviously it is a combustion reaction. So whenever you are seeing a combustion reaction, I told you the technique. What is the technique? First of all, balance carbons. Balance carbons. How many carbons are here? 4. So write 4 here. Next step is balance hydrogens. How many hydrogens are here? 10. You can write 5 here. Now count the number of oxygens on the product. So how many oxygens are here? 4 2s are 8 plus 5 1s are 5, which is equal to 13. So we have to write 13 by 2 here. But you know 13 by 2 is not a natural number, right? So that's why we are going to multiply the total equation with the denominator. Who is the denominator here? 2. Now tell me. 2 times C4H10 plus 2 times 13 by 2 O2 gives rise to 2 times 4CO2 plus 2 times 5H2O. Now tell me. 2C4H10 plus 2 will be cancelled. It will become 13O2 gives rise to 8CO2 plus 10H2O. Now see. Carbons are 8. Carbons are 8. Hydrogens are 20. Hydrogens are 20. Oxygens are 26. Oxygens are 8 2s are 16 plus 10 is equal to 26. Isn't it interesting? Easiest way to balance a combustion reaction. Okay, hope you understand. You practice. You take 2 or 3 equations and try to practice them. Now we'll go to the next question. That is, in the reaction Na2SO4 plus 2BaCl2 gives rise to BaSO4 plus 2NaCl. What is the precipitate here? What is its color is the question. So first of all, we will write the chemical equation. Na2SO4 plus BaCl2. Okay, I am writing here. Na2SO4 plus 2BaCl2 gives rise to BaSO4 plus NaCl. Okay, so let me tell you, this is a okay. I think we have to balance it. Okay, so Na2SO4 plus BaCl2 gives rise to BaSO4 plus NaCl. See, Na2SO4 is a white colored salt. BaCl2 is also a white colored salt. You are going to make it into aqueous solution and aqueous solution, both are mixed together. Then we are going to find BaSO4, which is going to be formed below. It is a insoluble substance and its color is white, curd like color. Okay, and NaCl is just like water. Okay, so now Na2SO4 plus BaCl2 gives rise to BaSO4 plus NaCl. Here, who is the precipitate? BaSO4 is the precipitate. What is the color of the precipitate? White is the color of the precipitate. And tell me, what is the meaning of precipitate? The insoluble substance which is formed after the reaction and is going to settle down is called as precipitate. The insoluble substance which is going to be formed after the reaction and is going to settle down is called as precipitate. That's why this reaction, in this reaction, BaSO4 is the precipitate and the color of the precipitate is white. Okay, go to the next question. Okay, now what information we get from a balanced chemical equation? What information we get from a balanced chemical equation? So what is a balanced chemical equation? Okay, we know the number of atoms on the LHS and number of atoms on the RHS are equal individually, then it is called as a balanced chemical equation. So we can write reactant 1 plus reactant 2 gives rise to product 1 plus product 2. It is just an example I am giving here. Now from this we can say that what are the reactants which are participating in the chemical reaction, what are the products which are going to be participated in the reaction. We can say number of atoms of the reactants, number of atoms of the products. We can also say whether it is a endothermic reaction, then we will write minus Q. If it is an exothermic reaction, we can write plus Q. If any gas is released, we are going to indicate with up arrow. If any precipitate is going to be formed, we are going to indicate with down arrow. Any substances or states of the matter are there: solids, liquids, gases, and we are going to say if any aqueous substance is there, then we can write AQ. That means we can know about the states of the matter also. So these are all information that we can get from a balanced chemical equation. Okay, we'll go to the next question. The next question is what information, okay, which law is violated when an equation is not balanced? We have already discussed, if an equation is not balanced, it will violate law of conservation of mass. If an equation is not balanced, it will violate law of conservation of mass. Now look at this question. So it is easy to discuss this question. That is, balance C6H6 plus O2 gives rise to CO2 plus H2O. We have already discussed. Okay, this is a combustion reaction. Here you can clearly see, here CO2 and H2O are going to be formed. So our technique is same: balance carbons, balance hydrogens, count the number of oxygens here and write by 2 in front of it. Done. Now look at the next question. BaCl2 plus Al2SO4 taken thrice gives rise to BaSO4 plus AlCl3. Now try to balance it. Here Al2 is there. We can write 2 here. Here SO4 taken thrice is there. We can write 3 here. Okay. And you go and write 3 here. It is balanced. Okay. Now you want me to write? I think you can practice it. Now look at this. Fe2O3 plus CO, that is carbon monoxide, gives rise to Fe plus CO2. Now carbon monoxide is called as a reducing acid, okay, because it is going to remove oxygen. Now see, Fe2O3, here we can write 2 here. This is CO is here and here O3 is there. You see which number is going to be here. I think CO3, 3. So balance, here you can balance it. Here also you can balance this reaction. Now we are going to solve question number 17. Balance NH3 plus Cl2 gives rise